Hi there, my name is Sam Hirsch. In case you didn't meet me on the first day, I am the exam grading TA for this class, and I'll also be making a couple quick, just explanatory videos like this one, just talking about some basic concepts in this class. So this video here is just going to be talking about converting from binary to decimal numbers and back. So converting from decimal to binary. We'll just be focusing on positive integers right now, so there's no need to worry about decimal places or negative numbers or anything like that. They're just positive numbers for now. Now, some of you may be very familiar with this if you have been more on the computer science side, but others, this may be a much more difficult thing to grasp. So it definitely takes some time getting used to this. So I have a little document here, and I'll make sure that this is available in the notes in the comments under this video or in the description. So that you guys can find this PDF if you want to refer to it later. But let's just walk through it really quick. So, converting from binary to decimal. So, each 1 in our binary number is equal to 2 to the m in decimal, where m is the digits place in our binary number, starting from 0, right? So, this very rightmost digit here, this is digit number 0. So 0, 1, 2. So this has a 1 in the second place, and m is equal to 2. So this means that this number's decimal equivalent is 2 squared, 2 raised to the second power, which is equal to 4, right? Now this number has a 1 in the 0th place, so m is equal to 0. Therefore, this representation in decimal is 2 to the 0, which is just 1. So then we just, pretty simply, we take the sum of all of the decimal values of each 1, and we pretty much ignore the zeros, right? So this was just a randomly generated number, just a random binary number here. And we're going to take the sum of all of the 1s. So we have 2 to the 0. That comes from this digit, and then 1's place is 0, so we ignore it, and then the 2's place, this is 2 squared, 3's place, 2 to the 3rd, 4's place, again we ignore it because it's a 0, and then 5 and 6 get added in, so in the end we have 2 to the 0 plus 2 to the 2 plus 2 to the 3rd plus 2 to the 5th plus 2 to the 6th, which is 1 plus 4 plus 8 plus 32 plus 64, which finally is 109. So that is the basic process for doing this. Unfortunately, there is not a super quick shortcut. The best way is in general just to take these numbers and add them up. And then you can finally add them in any way that you want. If you want to break this down into piecewise form, whatever, or if you want to, do classic grade school addition where you put them all on top of each other and that whole thing, that works pretty well as well. Alright, now converting from decimal to binary is a little bit more difficult. There are kind of two main processes that you can go through, and you can decide whichever one you prefer. I'm a more fan of the second one, which I'll go over in a second, but some people think it's more complicated and harder to remember. So when we are converting from decimal to binary, we're going to start with our decimal number. We'll call it n. We want to find the largest power of 2 that is less than or equal to n, right? And then we want to place a 1 in the mth place in the binary number. So this is like the reverse of what we were just doing to convert from binary to decimal. And of course, remember that the first digit is the 0th place. Then we want to subtract that from our original number and repeat until n is equal to 0, right? So how we do this, we start with n equal to, this is an example here. Let's say n is equal to 42. So the largest power of 2, if we count up, we've got 0, 2 to the 0 would be 1, 2, 4, 8, 16, and then 32. And if we go one more power up, we get to 64, right, which is greater than 42. So 32, that's 2 to the 5th, is our largest power of 2 that we can use. So that means we are going to put a 1 in the 5th place in this number. So we count over 0, 1, 2, 3, 4, 5, and that's where our 1 goes. And we fill in zeros with everything else. So far, we're not done yet. So now we take our number, we subtract 32 off. Now we've got 10. So now we repeat. Largest power of 10, we've got 0, 1, 2, 4, 8. Sorry, we've got 1, 2, 4, 8. I counted wrong there. And then if we go one further, that's 16, which is greater than 10. So 8 is our largest power that we can use here, which is equal to 2 to the 3rd, as you can see here. So now we're going to place a 1 in the 3rd place. So that's 0, 1, 2, 3. So now our number is 1, 0, 1, 0, 0, 0. We're still not done yet, because n is still not equal to 0. So we take n is equal to 10 minus 8, which is 2. Now our final power, we have the number 2. It's just 2 to the 1, right? 2 to the 1 is equal to 2. So m is equal to 1. And we place a 1 in the 1st place. So now we have 1, 0, 1, 0, 1. Right? And that is our final binary number, because if we took 2 minus 2, we now have 0. So that means that 42 in decimal becomes 101010 in binary. Now if we were to go backwards, if like we talked about up here, if we wanted to go back to decimal, we could prove it. We could check our work, right? We could see, we essentially just add up. We take this number, which we know is 2 to the 5th, because that's how we generated it in the first place. And we've got 2 to the 3rd plus 2 to the 1st, right? So that is 2 to the 5th plus 2 to the 4th plus 2 to the 3rd. Or sorry, 2 to the 5th plus 2 to the 3rd plus 2 to the 1st. And I can go over to Wolfram Alpha plus 2 to the 3rd plus 2 to the 1st. And that gets us 42 once more. Right? So hopefully you see how that is working out there. Hopefully it makes a little bit of sense. So that method is pretty much exactly the reverse of what we did when converting from binary to decimal. Right? We just did it in reverse. Right? This other method, I prefer this method because I think just the work for it takes up a little less space, and you don't have to do all these subtractions and stuff like that. But you also have to remember a new formula that is a little bit difficult to remember. So I have sort of this flowchart here. We start with a decimal number, n. Is n odd? If n is odd, we're going to place a 1 in our binary column. In our binary column. Then we're going to divide n by 2 and round down. So that means that if n is an even number, let's say n is 8, we'll divide by 2 and we'll get 4. But if n is an odd number, so if n is 7, when we divide by 2, we would get 3.5, but we're going to round down, so we get 3. Right? Now, is that number equal to 0? So the only case that will happen is when n is equal to 1, right? When n is 1, we divide that by 2 and round down, and we get 0. So if n is equal to 0, we are done. We reverse our binary number, and we're done. And that is it. And I'll show you exactly what I mean by that. If n is not equal to 0, we're going to go back, and we're going to check if n is odd. So I'll do this a little more in depth with these examples. So what do I mean here? So let's say we're converting the decimal number 4 into binary. So we start with 4. Is this odd? No. So we put a 0 here. Next, we divide by 2, so now we have the number 2. Is this odd? No. We put another 0. Finally, we divide 2 by 2, and we get 1. Is that odd? Yes, it is, so we put a 1 here. Right? So now we have the sequence 0, 0, 1, if we're looking down our columns there. and then we reverse it, and that gets us our binary number. So that tells us that 4 in binary is 1, 0, 0. And if we wanted to check our work, we could just convert this number back into decimal, right? So we have a 1 that is in the 2's place, right? Because we've got 0, 1, 2. And so that is just 2 squared, which is 4, right? So this method is not quite as obvious, but I think it's a nice trick that can help you do it a little faster. So here's just a more in-depth example showing that it even works with odd numbers. So here we start with the number 17. This is an odd number, so we put a 1. Then we divide by 2, so we would get 8.5, right? But we're going to round down, so we get 8. This is an even number, so we put 0. We divide by 2. 4, even number again, another 0. 2 is even, so we put another 0. And then finally 1 is odd, so we put a 1. And then we reverse this sequence, so we get 1, 0, 0, 0, 1 as 17. And you guys can go through and check my work on that if you don't believe me, or if you just want to practice your binary to decimal conversions. Alright, I hope this was helpful for you guys. Please feel free to reach out if you need some help with this. Converting between binary and decimal can definitely be tricky. Alright, thank you.